We are now presenting the second part of the assembly of the moving parts for a simple car engine that we started in the last presentation. Before we go on, we just want to notice that several modifications were made to the concluding model from the last lecture. The first is to reduce the eye of the small end of the connecting rod from 20 to 15. Then we concurrently reduce the pinhole in the piston to the same value and create a pin through the connecting rod overhanging the piston as before. With the same center 3, we draw a circle diameter 20 and extrude it on an offset plane to join the big end of the pin. A side hole was created at the bottom of the pin by extruding a circle 2 from the YZ plane symmetrically before both ends of the pin are fitleted to obtain the shape shown. The modifications on the connecting rod side, we just show it briefly here. You will see it fully in the video as what was done exactly. But these details are good here because they are clearer than what you will see in the video that will come next. And then the screw hole also is going to be shown fully in the video, but this static image might also do some good. We can see the con rod head. Now this is how we apply the cutting plane to the con rod. Again, this is the cutting plane. What you are seeing here is the piston, which is we are looking through the piston we are looking from the top section to see the con rod here. So here the plane of cutting is chosen this way. You can see it completely encloses the profile of the connecting rod. So when we cut, before cutting, we first of all switch off all the other elements so that only the connecting rod is cut. Now the assembly begins from this point. You can continue looking at the slides to see full written explanation of what's going on in the assembly, but you can now move from here to the video and take a full look at the video because the assembly is fully defined, fully described in the video. The only thing we will do is to quickly move to the end of all these other ones are explanatory, and then look at the issue of firing sequence, which you can get more information on that by going to the link shown. You can see the firing sequence we used and other firing sequences that you might want to consider yourself. The kinds of joints are discussed here. Then how we replicated those joints. This is the first set of firing sequence that we decided to use. That firing order is 1, 3, 4, 2. And we explained both in these slides and also later on how we arrived at that. Then we lastly discussed the issue of the offset alignment between the plane of sliding of the crank of the piston and the crank itself, the crank rotation. In this particular first picture, you see that everything is fully aligned. This is the center of crank rotation and this is the plane of sliding of the piston. Here, this is the center of crank rotation and this is the plane, and then lastly this is the furthest distance you can get between the center of crank rotation and the piston here. This particular arrangement allows the firing of the piston to come at right angles to the line joining that plane to the axis of the crankshaft. Of course, from mechanics we know that this is what theoretically should give us the best delivery, but in practical terms there are so many other considerations, from the balancing of the rotating masses and the friction and so many other considerations that allow manufacturers to choose somewhere in between this extreme and this extreme. So you are likely to see something more like this than either this or this in a real working. We begin this section from the complete single engine position we reached at the last lecture. At this point, we just make the modification on the connecting rod and at the crank end of the connecting rod. And you can see this rectangular object here that was created by doing a sketch. The sketch is what you can see now. That sketch, maybe we should edit that sketch to take a closer look at it. That is the sketch. The sketch is this 25 by 15. This is 25 by 15 center rectangle here. And then let us say end sketch. With that sketch in there at the origin plane, at the ZX axis, ZX plane at the origin, we are now able to do an offset extrusion. Offset extrusion because we're going to extrude, but the extrusion is not going to start from here. It's going to start from around the rim of this inner circle, and it will be extruded out. To see that extrusion in full, we can edit that feature, and you can see that extrusion is now pointing in the right direction. So it shows the object to be extruded, but the offset plane is chosen to be 25 millimeters away from the creation of that rectangle, and it moves a distance of 20 millimeters in the negative direction. That's why it's minus 20, and that is that. We move forward a little bit from here, and we now take a look at what we did to the con rod here. After filleting, we drill a 10 circle there, and then we use a 15 circle to create some space around the connecting rod for the head of the screw. All these things are mirrored. We do mirroring to the other end, and then mirror those faces again to the other side of the connecting rod. So having done that, we are then in a position to begin to now create a cutting plane. After cutting the connecting rod using that cutting plane into two, we can see that the upper part, the lower part, and that cutting plane. If we go into the browser, we will see that the connecting rod that was a single body under the body section of it is now a component made up of two bodies. So if we mark this, you see the head of the connecting rod and then the main body of the connecting rod. So the next thing we do is to turn this into a component by right-clicking on it and choosing create components from bodies. If we right-click, that will be the third in the drop-down list. So if we click on that, immediately that is changed, and that new component we are now able to call. We can now rename that component, say, and call it con rod head. If we do that, we will see now that the connecting rod is now a component on its own, and then there is another component called the con rod head, which is located inside the connecting rod. It is time now to begin our assembly of each unit before we proceed to the replication creation of the other cylinder units. First of all, we begin with the assembly of the piston inside the cylinder. Notice at this point that we have anchored the cylinder by making it grounded. The cylinder itself, the cylinder block, is grounded, but we want this piston to be able to move in a vertical direction along the axis of the piston always. No other movement is permissible. In order to do that, we choose the as built joint command. And when we get the as built joint command, we select the piston and the inside the cylinder. We can, any point on the cylinder will be okay, any point on the cylinder block. And the connection between the two is actually a slider connection. And that slider connection is shown here by the sign that we have put here. And then we are prompted to, as we choose the slider connection, we are prompted to select the area of the sliding. So at that point, we select the inner surface of this cylinder, and that inner surface lightens up for us to select it. And once we select that, and we have chosen the sliding joint, this is complete. And to show that we have completed that, we are in a position to test that. And to test that, we say animate joint. If we animate that joint is animated by showing that this piston will only move in the direction that has been shown. So press escape now to turn that off. Then the next joint we will look at is a joint between the connecting rod and the piston pin. Connecting rod and the piston pin, that joint itself can only be seen if we switch off the piston main body. We cannot switch off the piston main body by clicking the light of the piston off, because if we do that, the piston and the spin will both go. We have to now go to the bodies. We took in the bodies, we can pick within that component, we can pick the body that we want to switch off. So now we can see the connecting rod as well as the piston pin. In this, it is a good idea at this point to also switch off the cylinder head itself. If we switch off the cylinder head itself, everything is now shown. So to connect this piston pin to this crank end, we select as built joint, and then we select it asks us the drop down menu here asks for components to be selected. The first component here is the pin inside the piston. So not just any ordinary pin, it is the pin that is a component on its own inside the piston. So we take that. So that is marked. Then the second component we need is the connecting rod. Okay, so we mark that. So it has chosen both of them, but because this hasn't been taken away from rigid, it's already assuming that they are supposed to be rigidly connected, which is not the case here. So we change that to revolute. So as soon as we change that to revolute, it is now requesting, it's now making its third request from us. It wants us to show which position this joint will be revolving on. So we have several. So one good one is this point. So, but again, this is not good. The reason why we have it like this is that we chose the piston first before the connecting rod. In actual fact, it may not matter, but for us to be consistent and logical, it is better for us to see that it is the connecting rod that will actually be revolving around the piston. Of course, the theory of dynamics shows that one body revolving another is the same as the other body revolving around the one. But for our physical satisfaction, we should normally pick the object that is going to revolve first. So I want to stop this and select the objects afresh. I select the object afresh by first of all selecting the connecting rod. So I select the connecting rod, then I select the piston pin. Okay, so if I select the connecting rod before the piston pin, you can see that in the animation demonstration, it is now clear that there is a revolute joint between the connecting rod and the piston pin, and everything about this joint is now correct. So we can press OK. So having pressed OK, we can now bring the piston body back on view. So the piston body is now can now be viewed, and everything is okay on that side. The next one will be the connection between this the connection between the piston and it will be called the connecting rod and the crank. That again is a revolute joint, just like the one we have just done. The process and is exactly the same. So I will just give a demonstration of this joint now, and that joint is can be animated here. So that is the joint. It's also by an as-built joint. So we have that. So the next, the joint we had done before at the beginning, that's our first joint. We can repeat and animate that joint. That is the joint between the crank and the stator. That is that's also there. And here we have another as-built joint, which is okay, that is the as-built joint that we did just now. So okay, with this completed, it is possible for us to bring back our cylinder, the cylinder show, and we can actually animate the model. That is, we are not when we animate the model, we are not looking at what happens from one joint to the other, one joint to the other, one joint to the other, or this joint to this joint. We animate the model so that the logical connection between all the joints will actually be demonstrated. If we do animate model here, in the case of when we animate the model, all these joints are moving. Okay, there's a mistake here, which is we can't see the joint between the connecting rod head and the connecting rod itself is just left behind. So let us go back and correct that. Okay, so this connection is something we can also do with an as-built joint. Okay, so in order for us to see that, let us switch off the other parts that are not really part of the show. Okay, now we can see this very clearly. Okay, and we again pick an as-built joint. Here, the bodies that we want to connect, we want to connect the component, that is the head of the connecting rod and the connecting rod itself. Okay, and the relationship we want here is a rigid relationship, because in their motion they must be connected rigidly to each other through the motion, and we select OK. So we can go back to where we were before. We can go back to where we were before and repeat that. Okay, let's turn on the crank. If we now repeat that model again, okay, we can see that at this point the animation picks up the crank head, because it is rigidly because in its rigid connection to the connecting rod head, because in its rigid connection to the connecting rod, they must be together in all their motions. So we can switch this off. At this point, we are now in a position to do a pattern replication of each of the complete cylinder units. The complete cylinder unit will consist of let's look at the bodies now. It will consist of the crank. It will consist of the piston, the whole piston, the crank assembly, the piston assembly, because the piston assembly includes the piston itself and the piston's pin. It also consists of the con rod assembly. The con rod assembly containing the connecting rod and its connecting rod head, which is a sub-component with it. We are going to take this, we are going to do a pattern now of this entire assembly into the remaining 4 cylinders. And so let's go and do that. So in order to do that, we just choose create pattern. create pattern. Here we are taking a rectangular pattern, and in the drop down menu is set to faces. We are not replicating faces, we are replicating components. So we say components, and then we are now prompted to select the objects in the component, and now the objects are going to be the connecting rod. That is the object number 1. This time the connecting rod is being carried along with whatever subcomponent that is under it. Then the second thing is the piston. Again, that automatically includes the piston as well as the piston pin. Then the next thing is the crank itself. So, but we will not select the stator because that's not part of what we are looking at. And now we are selecting this, and then what direction do we want? We want to choose what direction to go. The direction to go in this case is the X direction. So we're going to select the X axis, and the origin is turned off. So let's turn the origin on so that we can see the X axis. So we are going along the X axis. That's the pattern direction. The distance type. The distance type we are going to choose is the spacing in between each of the units. So we are choosing a distance type that tells us we are taking the spacing in between. And we are also asked for suppression. Suppression asks us, for instance, we may decide to suppress 1 or 2. Let us say we are creating 10. We may decide to suppress number 7 and number 9. So it will create all the other ones except those 2. But here we have no suppression in mind. So in the quantity to be created is 4, because that quantity indicates not just the new ones but the old one, the total quantity we want. And now we are prompted for the distance, and the distance is the period of 130. And then this thing is moving in this direction. We want it to move in the other direction at a distance of 130, so it's minus 130. 130. Okay, it's minus 130. We can see already that each of these things seem to have found their exact positions because of the calculation we've already done. And now, because we want this rectangular replication only to happen in one direction, we are only going to choose that there. So we're going to choose so we have everything is in place now. So we are able to at this point we can now accept and say okay. So with this we have done the replication that we want to of the elements that are important. Everything is now replicated, and let us see, as we have already hinted before, out of this joints that we have made, some are already transferred by this replication. The connection between the component within the components, for instance, the connection between the connecting rod and the connecting rod head is this. These are the things indicated here. They have been transferred. Similarly, the connection between the let us open up now by switching off let's switch off this cylinder, the main cylinder. If we switch it off, we switch off the main cylinder, and then we take off the piston. Let's see, if we take off the piston's body, we can see there's not that, not even the piston. Let the piston body remain. The connection I want to show is a connection between let's just go to the bottom and look at it. So at the bottom, let's switch off the crank. Let's switch off the crank. Then let's see what crank that we can see here. Let's switch off the crank. Okay, we should switch off crank 2, and then let us switch off the connecting rod that is at that same point. Now you can see inside here the connection between the piston and the piston's pin are still have been transferred just because of the replication we have done. So since we did it before the replication and there are connections within the component, they are transferred when the component itself is replicated. So we can bring these ones back on, bring the con rod back on, and then bring the crank tool back on. So we go back home now. We go back home, make this thing a little bit bolder. So let us use this. So with this, we have this situation now where all the four are there. But before we can finish, we now have to effect the other connections. So we begin with the connection between the second piston and the cylinder. And for us to do that, we again appeal to the as-built joint. As-built joint, the first object now is the cylinder, which is selected. Okay, the next object is the piston, which we can select. Okay, still, then let us go back and then get the cylinder. First object is the cylinder. Okay, now it is again assuming rigidity, and that's why that's shaking. So, but we don't want rigidity. Here we want a slider joint, and then it asks us to choose the position. The position is the internal surface of this cylinder. So to demonstrate it knows what we are talking about, it gives us an animation, and that is okay. The next joint we need to work on is the joint between the connecting rod and the crank. So we again go to as-built joint, and then the objects are, in this case we are now talking about crank 2. No. That would have been okay, but that's not the order we want to use it. We want to first of all select the connecting rod 2 and then crank 2. We select the object that is revolving about the other one. So now we are asked for the position of we are prompted for the position of that motion, or that so this position is okay. There are several we can choose from. Oh no, okay. Now it thinks that because we haven't changed the type from slider, so we need to let it know that it is a revolute joint. So the revolute joint, that is it. So once we say okay, that is also done. Okay, we now rotate the cylinder. This is the big one. We are now to rotate the cylinder to its final destination. So if we rotate the crank, we rotate the crank to its final destination. We do that by clicking on crank 2 and ask for a move copy. So the move we want is a revolute move, and if we want that revolute move, we might just do that revolute move to an angular orientation of 120. So but before we do that, we have to select the axis. In this case, the axis is the axis of the crankshaft. So this is axis of the crankshaft, and the degrees is 180. So again, like we can see what has happened here, if we look very carefully, okay, we have a problem. It left the connecting rod behind, and that means that we have not connected the connecting rod to the pin of the crankshaft. Remember, because these two connections, so we have to first of all undo that motion, and before we move on, we must connect the crankshaft. We must connect the connecting rod to the pin of the piston. In order to do that, we have to turn off the cylinder again. This cylinder has to be switched off. Where is the cylinder? Okay, cylinder has to be switched off to give us access. We also have to take the piston 2 off. The piston 2, not the whole piston, but the piston body must go off. So with the piston body going off, the pin is exposed. So we have, just like we have done for the first portion, we have to repeat that for this second portion. So we are going to now bring down our menu for as built joints, and the objects now, the first object is con rod 2, and the second object is inside the piston 2, and that is pin inside the piston 2. So these two are selected, and we need to select the position for the rotational motion we want. That is it. Okay, and then we select OK. After selecting OK, we bring back the things we turned off. That is, the cylinder comes back on, and the piston's main body also comes back on. Okay, having done that, we are now in a position to rotate the crank to its final location. So we rotate the crank. So we are going to choose crank 2 here, and we are going to choose move copy. And in move copy, one object has been selected, that is crank 2. We are already, the move type is a rotational move, and the axis of that motion, is the crank axis, and the degrees we want is 180. So at this point, we have, without doing all the calculations, we don't need to do any calculation. The piston is forced to go to its correct position because of the joint between them, and the crank, the connecting rod is also, we have only rotated the crank, but the connecting rod, the piston spin, every other thing cooperated to go to their, again, we have laid the piston bare, so we can connect the con rod to the piston pin, again using the as-built joint for the third cylinder. As-built joint, first object to be chosen, as we discussed before, is the connecting rod, and then the second object to be chosen is the piston pin. And to get to the piston pin, we have to open up the piston 3, and then we get in there, we choose that pin. So before we choose the position, let us notice that that is a revolute joint, and then we go to select the position, and then the position of that motion is there. So that is done. We accept that. That's okay, and then we bring back the objects that we have hidden, and at this point we are now to connect the have we connected this? But we still need to connect the lower end of the piston to the crank. So we now bring again another as-built joint, and then here we take the crank 3, the connecting rod 3, we now meet with the crank 3, and then the position for that joint action is here. Okay, it's demonstrating that it knows what we are about, and we accept that. So everything is ready. Again, let us rotate this second crank into angle 180. So we take the crank here, crank 3. You can see crank 3. Yes, this is crank 3. And then we select, we right click on it, and then we do a move copy. The move copy is a rotation. The body is already selected. Rotation, move type rotation is selected. The axis of rotation is the angle of the axis of rotation is the axis of the crank, and then we want that rotated 180. So no mistakes this time. It is rotated 180 and everything arranges itself as accordingly. So we say OK, and then lastly we now join this crank to any of the static objects. Now in joining the static objects, they do not have to touch each other. They only have to be in the correct positional relationship with each other. Once they are, we can join. So we have the choice at this point of joining the crank 3 to crank 2, which is its immediate neighbor, or joining crank 3 to crank 1. So just for illustration, I'm going to join crank 3 to crank 1. That is not touching it, and the joint is going to be a joint of rigidity. So assemble as built joint. We capture position of the last work done. So that's capturing the position of the last rotation. Then we select object. The objects here are crank 3 and crank 1. So the joint we are looking for is a rigid joint. So that rigid joint is selected. So we can say OK. So we now have the 3 cylinders completed, and we can test the joint and see. Okay, so this joining have been done correctly, and then we can stop. The last one is the joint of the 4th section. So we do that now. Just like the other 3 cases, all the external connections of the crank of the 4th cylinder have been done. Now what do we do next? In this case, we do not want to rotate the crank, so we want to leave the crank in the position it is. So all we have to do now, after doing all the other joints, is to connect the crank to any of the 3 cranks that are already ready. So in this particular case, we connect it to the crank that is immediately before it. So we are going to connect crank 4 to crank 3. So as built joint, so we are going to connect crank 4 to crank 3, and the connection is a rigid connection. We click OK. So we click OK now. We are now in a position to test all 4 cylinders by just asking for there to be a demonstration of the model. So animate model animates all the. So we can now take a look at the complete model, which we have done. We can look at it from several views. We can look at it from the head view, from this view. We can look at it from top, and then from this side. So then we can take any oblique. We can take any oblique look at this thing. Okay. And that is it. Thank you. The firing sequence of these cylinders is actually 1, 3, 4, 2. It doesn't, to the untrained eye, it looks as if it is a firing order of between 1, 2, 3, 4, but it is not. It is 1, 3, 4, 2, or 1 and 4 firing before 2 and 3. That's not the case. The reason for the apparent contradiction is that while we think in 360 cycles, the 4-stroke engine thinks in 720 cycles. So if you are going to have firing order of 1, 3, 4, 2, the 4th cylinder is at angle 0. The next cylinder to fire will be at an angle of 180 degrees rather than 90, because we have to divide 720 into 4 places, which gives us 180. So because cylinder 3 is going to fire next, so cylinder 3 is at 180 degrees rotation from cylinder 1, so it fires next. The next cylinder to fire is cylinder 4, which is going to fire at 360 degrees rotation away, and 360 degrees rotation will appear to us as 0 rotation, because 360 in our own cyclic thinking is the same thing as angle 0. But for the cylinder, angle cylinder 4 is at 360 degrees. And the last cylinder to fire is cylinder 2, which is oriented at 540 degrees. 540 degrees because of our circular, again, period of 360. 540 coincides with 180. So this cylinder orientation is actually 1, 3, and so 1, 4, 1, 3, 4. Furthermore, let us observe that the cylinder as arranged is actually having the cylinder axis misaligned from the crank rotational axis through this distance, which I will show here. We can easily see that from a right view of this whole arrangement. You can see that the axis of the, here you have, this is the axis of the cylinder, and this is the axis of the crankshaft. This misalignment is equal to the rotational distance of the crank. This is full misalignment. In actual fact, most modern vehicles are not designed to have full misalignment. Theoretically, simplistically, I would say, this seems to be the best thing, because the firing point, at the firing point, the full thrust of the fire will be applied to the crank at 90 degrees, which is the way we will crank our bicycles if we are pedaling a single bicycle. The empirical experience of the manufacturers did not allow them to give it full misalignment. Rather, the misalignment is usually somewhere in between full alignment and this extreme case. In order for us to put it somewhere in between, I am going to rotate crank 1 through angle 45 degrees. If I rotate crank 1 through 45 degrees, let's do that. This view is very good for that. So just right click and say move copy, and then we have already selected the body to be moved, which is crank 1, and then the rotational type, and then to select the axis of rotation. The axis of rotation, in this case, the axis of rotation is well, we have to decide. The axis of rotation here is the crank pin is the connecting rod pin on the crank. So let us do a 45 for that rotation. So I'm choosing this, and then we're choosing like a 45 degree rotation for this. In order to move the crank plane closer to the plane of sliding of the piston, we would need to rotate the crank through 45 degrees around the crank pin. Let us try and do that. We do that by selecting crank 1. When we select crank 1, and then we choose move copy by right clicking and selecting move copy, we are given this drop down menu. The object is selected, the move type is rotational, it's already done. So the axis, to select the axis, we select the axis of the connecting rod pin. So let us now try to do this rotation. We try to rotate through 45 degrees. Nothing happens. Nothing happens. Why? Why is nothing happening? The reason is that, remember, the stator here is immovable, is grounded. To move this through any angle whatsoever is going to result in a motion, in a displacement for this grounded object. And the only way that can happen is that we must cancel right now and not do anything and go to the stator and unground it. So we go to the stator, right click and unground it. Once we have ungrounded the stator, we can now rotate the crank any angle we like. So we can go back again and try. To try, we again go to crank 1, right click, select move copy, 1 selected, and then everything is okay. The axis chosen, again as before, is the axis of that axis of the pin, and let us select minus 45 degrees here. So minus 45 degrees is like that. If we took 45 itself, it would be like this, 45. So if we click OK now, OK, and then we take a right view of the whole process, we can see that the rotation has brought this axis closer to this to the plane of sliding of all the pistons. So we can accept that if we're happy with it. So the next thing is to go back again. Let us not forget to ensure that the stator is back to grounded. So it asks us, in order for us to implement that, whether we want to capture position. Yes, capture position, and then we can go back again to our animation of this model. And then again, everything is as before, with the axis of the crank closer now to the plane of sliding of the pins, which is more likely to be what you will find in a working vehicle. That is it.